Remember that you're starting with the calculator portion. The calculator portion is actually brief. It's only, like, there's 4 questions on that portion, and you only even need it for 3. The one, like, if you're at a single rate where you have to do your 0.001, obviously something like that, you would have your graphing calculator for. Your rate of change, if the numbers are complicated, that kind of thing, you'd have your calculator for. So let's go page by page. Any questions on this first page of the Unit 1A review? So we're talking dependent and independent variables. You want to be able to identify that from a statement. Determining, and be careful here because remember the wording here changes later. This says, is the function increasing, right? Not, is the rate of change increasing? If it's asking if the function's increasing, I'm simply just looking at these values. As those are increasing, these values are increasing. Now my function's increasing. What if it had asked for the rate of change of the function? Is it increasing or decreasing? What would you have to do first? Yeah. You'd see if it's concave up or concave down, so you'd actually have to figure out your rate of change, right? You'd have to do like 12 minus 8 over 11 minus 9. Then you'd have to do 15 minus 12 over 12 minus 11. Then you'd have to do 17 minus 15 over 15 minus 13. And then you'd have to do 18 minus 17 over 17 minus 15. And if it's that rate of change is increasing, then I would say the rate of change is increasing or concave up. If that rate of change was decreasing, then it would be obviously a rate of change that's decreasing or concave down. So be really, really careful with the wording on these. It's either asking if the graph is increasing or decreasing, or it's asking if the rate of change is increasing or decreasing. Those mean 2 different things. All right, you will have a diagram where you do have to identify where it is increasing and decreasing, where the concave up or concave down, where the zeros are, where your y-intercept is. So that's one of the questions that's got multiple parts on it. Hopefully we feel confident with this one. And then here's one it says calculator active, right? So this would be one that you would have to do with your calculator. This would be on the calculator part. And in this case, I would strongly recommend you take advantage of your y equals. I would type in my y equals 1 minus 4, the square root of 1 minus 4r. And then I would do the y1 of, what's the second number? -1 minus y1 of -5 over -1 minus a -5. And let the calculator do the work for you. The good news is that's multiple choice, so hopefully you'll catch it if you're way off. But the trick on that means there's going to be distractors. So look for things like the wrong signs, that kind of thing. Be really, really careful when you make that choice. Questions on this page? Okay, then we got into your rate of change given the chart. So you want to hone in on just the ones that they're talking about, the 135 and the 200. Or the 24 and the 135, or the 24 and the 200. Another, this is calculator active. This is also calculator active. If you got given this chart with more simple values, this could also be on the non-calculator part. So I would say it just depends on what those values are. You might also have a question like that on the non-calculator part. Nancy?
For number 6, would you put it in the calculator as -0?
So I actually would have done -1. This one, it doesn't matter. Both those answers are not going to be there. So like if you go to do this question and it's positive, we go up. This is negative, it's still going up. So you could use either one, but one or the other will be there, not both, if that makes sense. Like if you go to do -1.001, it won't be there in your answer. So then you'd know this is up, right? That is 0.0001 up from -1. You won't see it. Like if I give you a negative number, right? The answer that's there is going to be using the number that is 0.001 bigger than that answer, not less than. Does that make sense? If it was open-ended, I would have taken both, but this is on a multiple choice part, so it's only going to be one or the other. Yeah.
How many questions are multiple choice?
Oh, 10? I think it's 10, and then the rest are open-ended. Yeah, and there's 18 total. All right, obviously being able to identify if it's got a positive or negative rate of change, which means this would be concave up, or concave down. Make sure we know that those both mean the same thing. God bless you. Finding your rate of change given those values for 8 and 9. So this is how you could see it if it was not with the calculator. And number 10, it says to find the rate of change. Remember, if it's linear, then the rate of change is your slope. And the rate of change of the rates of change would be 0. So your second difference. For 11, the rate of change is going to change because it's quadratic, but the rate of change of the rate of change should be consistent if it's quadratic. Second difference there. So I would like literally go to my question and I would underline or circle rate of change of average rates of change to see it twice to know it is not just rate of change. If it was just rate of change, for 10 it'd be 5. For 11 it would depend on the interval, so it couldn't ask you that unless it gave you the interval. Otherwise you get different answers. All right, 12, now we're just doing the same thing but from your chart. So now it's asking for the rate of change, or which would determine your concavity. 13 and 14, leading coefficient and degree. 15 and 16, guaranteed extrema. So it might, for my view, like I actually like to plot those things to see what they look like. So maybe I would recommend the same thing. Like if I had, this would be 0, -3, this would be 4, 0, and this would be 7, 0. 0, -3 is down here. 1, 2, 3, 4, 0, 5, 6, 7. So I know it's going to go up and come back down again, or come down and come back up again on that interval. And that's the only interval I can guarantee has a local extrema. So I would have done the same thing for 16. 17 is asking if it has a guaranteed max or min, or a global max or min. If my highest exponent is even, the answer is yes. If it is odd, the answer is no. If it's even, now we look at the leading coefficient to see if this is negative. Both arrows point down, which means there would be a maximum. If it was an even exponent with a positive on the front, now it would be both arrows pointing up, and then it would be a minimum. So this could say there's a global max, there's a global min, there's neither. Rolina.
What's the difference between a local and global?
Local means it could happen more than once. Global is there's only one max. So only on an even power can there be a global, because you know both arrows point down and both arrows point up. On odd, one's going up, one's going down, there's going to be no max, no global. So meaning this could happen on an odd, right? It could go up, down, up again, and these would be local max and local min. But absolute doesn't exist because those arrows point up and down. So odd, you cannot determine if there's an absolute. There won't be. Okay. And then your extrema from a graph. This is the other one that has multiple parts, or another one that has multiple parts. Your absolute min is the lowest point. It's cut off on the right there. My graph stops at a point, so that's 1, 4, or 4, 1. But it's at the minimum of 4 when x equals 4. There is no maximum because that arrow points up. Relative minimum would be both here and here, which is -1 and 4. Relative maximum would be here, where x is 1. Questions on those? All right. Then we got into so this one, they actually do like a sign chart. In my opinion, it's easier to graph it, but you could certainly do this sign chart is what they call this. Like this to me would be if I didn't understand end behavior. If I didn't understand end behavior, then I could plug in a point from each of the ranges. But now that you understand end behavior, I think it's easier to figure out where are my zeros. So I know there's 1 at 3, there's 1 at 5. So I know I have 1, 2, 3, there's a point, 4, 5, there's a point. And I have a positive x squared, which means my arrows are going to point up left and right. The multiplicity of those zeros is 1, so it's going to cross through and come back up. And this time it's asking where it's less than or equal to 0, so be really careful there because that could change. And that means it starts at 3, comes down, and continues below the x-axis until it hits 5. So 3 to 5 is where my graph is less than or equal to 0. For 24, my zeros are 0, -3, and 8. So again, I would, on my number line, -3, 0, 8. And it's an exponent that is odd with a negative on the front, so it rises left and falls right. The multiplicity of each of these zeros is 1. So it crosses through, it crosses through, it crosses through. And this time it wants it where it's greater than or equal to 0. So it's going to start here, come up above my graph, and end there, which means it is from, oh wait, yeah, and then here too. Greater than or equal to 0, from -infinity to -3, and then from 0 to 8. Yep.
What would it look like with the multiplicity?
Let's say my zeros were x minus 2 squared and x plus 1, let's say. So this has this is 2 with a multiplicity of 2, and this is -1 with a multiplicity of 1, right? So I'd have a 0 at -1 and 2. If I had expanded this out, this would be an x squared times an x, so this would be a positive x to the third, which means it falls left, rises right. It's going to bounce at 2, which means it crosses through here, but it comes here and it bounces off the 2. It does not cross the x-axis. So if it asked me where is it greater than or equal to 0, then it would be from -1 to +infinity because it stays above the whole way. If it asked me where was it less than or equal to 0, now it's -infinity to -1 because that's where it stays underneath.
So it doesn't cross through.
It doesn't. It literally hits and turns around. Yep. All right, 25 and 26, this is where, well, 25, they could give you the degree of the polynomial and then the list of all the zeros if there is any multiplicity, and it could ask you for your non-real zeros. Remember that the degree is the total number of zeros, and also remember non-real come in pairs. So if it asks for how many non-real and there are odd options, cross them out. It can't happen. So then I would figure out based on what the information they give me, subtract it away from the total and get the non-real. Number 26 gives you that there's a complex 0. If there's a complex 0, its conjugate is also a 0. 27 is where we determine what degree it is based on the number of times we have to find the difference. So first difference, if it was the same, would be linear, which is a degree of 1. Second difference is 2. Third difference is 3, so on and so forth. 28 is even because it's symmetric to the y-axis, and 29 is odd because it's symmetric to the origin. If it moved up, if it moved right, if it moved down, anything like that, it would be neither. Yep. All right, 30. This is your test algebraically. So I plug in the -x. If it goes back to the original like 31, then it's even. If every single sign changes like 30, it's odd. Then we've got our end behavior to describe your limit notation to describe your end behavior. Be really careful with these signs, okay? It's going to be multiple choice because there's 4 options, right? And one little negative messes that whole thing up. So be really, really careful when you make that selection. And then on the bottom, it just says sketch the graph in which it could. So this could be like a multiple choice question. Which of the following could match it would be what you would see.
How many total questions are
18. Yep. Yep.
On the last set of questions, is it fine if I just do the arrows, or is it?
Yeah, that would be multiple choice. So you'd see 4 choices and you'd be picking which one. Yep. Could it be? Any questions before I move on to the next one? All right. This was the one you had from, Wednesday, Thursday. So I posted these solutions, but I do want to, I'll kind of go page by page. So any questions on that first page? All right, so 3C says on what intervals is H decreasing at a decreasing rate? Okay, so let's figure out what this means. Decreasing means it's falling, right? At a decreasing rate means it's concave down. So I would have probably identified my concave up and down first. This would be concave up. This would be concave down. So now I'm only looking from the part that's concave down, and I need it to be falling or decreasing. It starts decreasing here and continues to positive infinity. So it's x is greater than 2. 3D says on which intervals is it increasing on an increasing rate. So increasing rate means concave up. So now I know I'm looking on the yellow part. And increasing means it's literally coming up, right? My y values are getting bigger, which happens from here to, well, here to here. Or -3 to 1. So 2 parts there. Yeah.
So you don't need to do greater than or less than for like the increase and decrease?
So a point can't be increasing or decreasing, which means you'll never get an or equal to, if that makes sense.
Are you gonna post the solutions for these?
I thought I did.
Because I can't get it.
All right, second page. This was a lot of true or false. Obviously, I'm not going to give you true or false, but this is a lot of like understanding the language type of questions. So it'd be true, true, false, true, false, true, true, false, true, false. All right, then a lot of rate of change. So this time it gave you the rate of change in 2 ways. This is a great, just so you know, this is a fantastic AP question because this is how it will happen. They will give you multiple functions. So in this scenario, you got f of x, that's an equation. You got g of x, that's a piecewise function. You got k of x from a data chart, and you got p of x from a graph. This is going to happen on your AP exam. So then based on what it's asking for, you have to pick which of these you're using. So obviously 14 says f of x. That means I plug it into that equation. 15 also said f of x. 16 said g of x. That means I'm using the piecewise function. So I have to figure out which of these equations I'm plugging it into based on the value and then plug it in. K of x is from your graph. From your chart. And p of x is from your graph. So you'd need to know how to find the rates of change using any of those modes of function notation. The equation, the piecewise function, the chart, or the graph.
How did you figure out 20?
20, so it says the average rate of change from -1 to 5 on p of x. So this is the graph. So I go to -1, I get the coordinate point, and that's +1. So p of -1 is +1. And then I go to where it's 5, and I get the y coordinate, which is 3. P of 5 is 3. So then I would do 3 minus 1 over 5 minus a -1. That becomes 2 over 6, or 1/3. So you're reading the y value with the given x.
So a question like this is going to be on the test?
Sure. In any of those ways.
So that would be the same for 21 as well?
Yep, 20 and 21 are both from that graph. So it says find g, you're finding g of 2 minus g of -4 over 2 minus a -4. G of 2, you have to look at your piecewise, right? 2 is less than 3, so I'm going to take the 2 and plug it into that 4 minus 2x. And I get 4 minus 4, which is 0. So that's 0. And then g of -4 is also less than 3. So I'm going to plug it into there again. 4 minus 2 times -4. 4 plus 8, which is 12. And then this becomes plus, and that becomes 6. -12 over 6 is -2. Good? All right, then all the comparisons of your rates of change. 22 concave up, 23 neither because it changes. 24 down, 25 neither, 26 up, 27 neither. And then the degrees. So 28 is the third degree because it took the third difference. 29, second. 34th, I'm not going to make it go that far, but you could eventually. And 31 is the first degree because the rate of change initially is constant. All right, then the top was your concave up and down. So 22 concave up because they're increasing, 23 neither, 24 concave down, they're decreasing, 25 neither, 26 concave up, 27 neither. And then the degree. So 28, the first difference the difference didn't happen, the same difference didn't happen until the third round. So that's a degree of 3, 29, degree of 2, 30, degree of 4. I don't even make you go to the fourth on this one, on this test. Okay, and then then 31, it happened the first time. So it's a degree of 1, which would be linear. All right, then last page, even, odd, neither. 33 was neither. 34 was even. 35 was odd, because we plugged in the negative variable. From the graph, 36 is odd, 37 is neither, and 38 is even. And then from the table of values, this one's a little bit trickier because you have to understand the pattern of your table of values. 39 said find the values of A and B in the table above, so you have to determine what's happening in your graph. It said K was even, so this one's even and this one's odd. If it's even, then it's going to be symmetric to the y-axis, so you should have matching values as you increase or decrease. And if it's odd, then the negative and the x and the y negative signs are going to change, negative and positive signs. Then it wanted you to find the individual k of -1, p of 3, and then it wanted you to find the rate of change from -5 to 5. Questions on those?